Hi guys, this is our video for our homework. I do apologize for not coming in until Tuesday, but I did still want to make the video. Because of our weather day, our mid-module is going to be moved to Monday, so hopefully this video still helps tremendously because it is geared very heavily towards helping the kids prepare for their mid-module. So let's start off strong. They want us to write this fraction as a mixed number. Okay, mixed number being a whole number and the fraction. We've been practicing doing this using number bonds in the classroom. So here we have 13/6. We know that a whole is when our numerator and our denominator are the same. So 6/6. Okay, that's one whole. We know that we still have enough to make another whole. So that'll be 6/6 again. And then 1/6 will be left over. To help with this, we can write down our multiples because this fraction bar does mean division. So how many times can 6 go into 13? Okay, you have your 6 and 12. Oh, that's only 2 times. So 2 wholes can be pulled out. And if we did 13 minus 12, that equals 1. So 1/6 is left over. Okay, our next question is to compare these fractions using the less than, greater than, or equal to sign. We've been using different methods in the classroom, reasoning, as well as finding like denominators. And so I think we're going to use the find the like denominators as our strategy because that'll be super easy. And this is like what I've noticed the kids are more comfortable with. So when I look at 4/6 and 7/12, I'm always looking for that relationship. No, there's not a relationship in my numerators, but there is a relationship here with my denominators. If I was to multiply 6 by 2, I get 12. And the kiddos know what I do to the top, I must do to the bottom. So if I'm doing 6 times 2 to get to 12, then I'm also going to do 4 times 2 to get to 8. So now we know that 4/6 is equivalent to 8/12. And now I can compare because my denominators are the same. And I always ask the kids, would you rather 8 pieces or 7 pieces or whatever we're comparing? And of course the kids are going to say 8. And so the greatest fraction gets the 2 dots and boom. So that tells us, I'm sorry, that was very raggedy, but that tells us that 4/6 is greater than 7/12. We're going to do that one more time with 1/2 and 3/5. Here we look and no, there might not seem to be an apparent relationship right away, but we can find like denominators by multiplying 2 by 5 and 5 by 2. So I come down here just to my little workspace, and I have 1/2. I'm going to multiply that by 5, so 1 times 5 and 2 times 5. And that equals 5/10. And then I have 3/5. And I'm now going to multiply 3 times 2 and 5 times 2 to still get my denominator 10. And 3 times 2 equals 6. Okay, so 1/2 is equivalent to 5/10. And 3/5 is equivalent to 6/10. So when I compare these two fractions, I know that 6/10 is greater than 5/10. All right, next one is which fractions are equivalent? Okay, those means equal. Circle and prove why. Okay, so this one can be a little bit difficult. I just want them to take the time to think, see if we can find any relationships, and then move from there. Okay, so as I'm looking, the first relationship that should pop out immediately is 4 tenths and 40 hundredths. And the reason that it should pop out immediately is because we have drilled the power of 10 this year. So for me to prove how or why these are equivalent, I'm going to multiply by 10 because that's what we've been doing all year. We should all be super comfortable with multiplying by 10. We know that 4 times 10 equals 40. 10 times 10 equals 100. So that tells us that 4 tenths is equivalent to 40 hundredths, okay? And then I'm going to make sure when I look at 4/6, do I have a relationship anywhere? I do with 4/6 and 4/10, but I know that those can't be equal because my denominators are different, but my numerators are the same. So then I look at 4/6 compared to 2/5, and I realize, oh, there is a relationship in my numerator times 2, but if I multiply my denominator by the same, that'll be 4/10. So, oh, it's not equivalent to 4/6, but it is equivalent to 4/10. So that also makes it equivalent to 40 hundredths. And those will be the 3 that are equivalent. All right, let's move on. This word problem is a little bit difficult, but we're going to take it step by step. Carl is riding his bike from Houston to Austin for a fundraiser for cancer research. Carl got in shape by riding his bike each day, 7 days per week, for the last 6 weeks. Each day, he rode 24 miles. How many miles did he ride altogether in the last 6 weeks? Okay? So, we're going to go back to those key pieces of information. Okay? Carl got in shape by riding his bike 7 days per week for 6 weeks. So, that's our first step. We know that we have 6 weeks. Week 1, 7 days. Week 2, 7 days. Week 3, 7 days. And so on and so forth, all the way until we get to week 6, which is 7 days, right? W1, 2, 3, ... in continuation, week 6, okay? And so we're going to have to find, well, how many days did he ride? Because it goes on to say each day he rode 24 miles. So we have to figure out, hold on, how many days did he ride? And we know, looking at our diagram, this is 6 weeks times 7 days. So that's our first step. Okay, Miss Henderson's going to leave you a little bit hanging because I want you to do some math all by yourself, all right? So this is going to tell us days. After we figure out our amounts of days, we then have to do step 2. And step number 2 is how many miles did he ride all together in that last 6 weeks, okay? So after you figure out your days, you're going to do the number of days times 24 miles to equal your total, okay? I know some of y'all going to be like, Miss Henderson, come on. But I really, really, really want y'all to take y'all's time and use your multiplication skills. Y'all got this. You can do a great, great, great job, okay? All right. All right, our next question is find the difference. We know that that's subtracting. And then it says to check your answer below with addition. All right, so this one, we're going to go ahead and review because we haven't seen a problem like this in a while. Okay, we have 30,000 minus 17,895. Okay, I know we're not supposed to say it, but bigger bottom, better borrow. I cannot take 5 from 0. 0 minus 5, if I have nothing, I can take nothing. So I'm going to have to go take away, take away, take away, take away. My 3 is going to become a 2. And then I can do the process of this becomes a 10, but I needed something. This becomes a 9. But we know that already. So we're going to say 9, 9, 9, 10. And now everything is fixed. We got this. 10 minus 5 equals 5. 9 minus 9, 0. 9 minus 8, 1. Bring down that comma. 9 minus 7, 2. And 2 minus 1, 1. Okay? Now, you're going to check yourself. Check yourself. Make sure that we're correct. So we're going to come down here. 17,895 plus 12,105. I'm going to leave that for you. Y'all know how to add. Y'all are geniuses when it comes to addition. So you got this, okay? Go ahead and add to make sure we got the right answer. And then when we come over here, we have to find the sum, which is adding, okay? So remember what we did in class. We have to start with like units or like units first. So I'm going to first add my 6/9 plus 5/9. My denominator is going to stay the same. Ooh. And 9 plus 5 equals 11. Okay, so we're going to rewrite it just to keep it organized. We have 3 plus 11/9. But do we realize something right here? Yes, we should. That fraction is greater than 1. So we're going to do our little number bond. We know we can pull out 1 whole or 9/9. Those are equivalent. And we will have 2/9 left over. So 11/9 equals 1 and 2/9. All right. Let's rewrite it one more time just for organization. Okay. If you don't need to rewrite it all these times, you're good. But Miss Henderson just wants to keep it organized. Okay. So now we have 3 plus 1 and 2/9. And now I can add this across. 3 plus 1 equals 4. And we have 2/9 remaining. All right, I hope that helped. If there is another way that you feel like you could have solved this, please feel free to share with us in class, okay? All right, we're almost to the end. The first number in the pattern is 93. The pattern follows the rule of add 71. So all throughout, you're going to add 71. I'll do the first part with you, but you guys can finish the rest, okay? We're going to do 93 plus 71. 3 plus 1 equals 4. 9 plus 7 equals 16, right? So 164. Remember, your rule is add 71. So you're going to do that again and again, okay? And here we go. Our last one is find the total amount of money. Ms. Henderson is just going to tell you the values, and I want y'all to solve with the money, okay? So here we have our values. This is worth $5. This is worth $1. Our quarter is worth 25 cents. Dime is worth 10 cents, and you have 2 of those. Your nickels is worth 5 cents, and you have 2 of those. And your penny is worth 1 cent. So you're going to add up. And I would first add up all of my change. After I add up all my change, then I can add it to my dollars. Okay? You guys got this. I know y'all are going to do great. I hope that this video is helping you. And I can't wait to see all of your smart thinking when you turn in your homework on Friday.